I'm a traditional DO, doing mostly family practice and focusing on sports medicine. I've done that since 2009. Primarily, my bread and butter is injecting PRP into people's joints, ligaments, tendons, you name it. And I've had great success with that. And I also oversee one of the 3 freestanding hyperbaric clinics in Colorado. And that's how I got into treating traumatic brain injury. Any of you guys treat traumatic brain injury? Ever seen some of those patients? Yeah. So it's kind of a unique case, a unique condition. There's not a lot of, past the surgical, past the neurosurgical realm, there's not a lot of good treatments for traumatic brain injury. Most of the treatments are oriented towards the post-concussive symptoms, the neuropsychological conditions that occur after brain injury. And so that's where a lot of the drugs and the medical management occurs with that. We have taken a multimodal, what we would call a regenerative approach to traumatic brain injury, because we feel like that's the only way to help brain injury patients really achieve sort of long-term maximum benefit. So thanks for coming, and if you have any questions, there'll be questions throughout the slide, and you guys can do the clicker if you want. I don't know if it's the clicker will work on this or not, but we'll see. So we're going to define what the biochemical and metabolic effects of TBI. That's probably the biggest etiology of what I'm looking at. It's not the neurosurgical, it's not intracranial pressure, it's not arachnoid subdural hemorrhages. We're looking at biochemical aspects of TBI as a etiology for understanding how to treat TBI. We're going to look at mainstream and alternative treatments for TBI and understand the regenerative model. You guys all probably know, anybody that's seen traumatic brain injury, know the symptoms. You get a headache, sometimes not. Photosensitivity, anosmia, seizures, cognitively you get confusion, slowed learning, psychological, frustrating. The biggest challenge of these injuries is they look a lot like everything else. You get depression, you get mood changes, you get irritability. A lot of patients will go to their mental health professional or a psychologist or even psychiatrist and have no idea that this is a brain injury because it looks like so many other things. And I think finding sort of a common ground, a common understanding of what's going on to create these symptoms long-term in TBI patients is the goal. So the sort of biochemical, this is just an overview, response to a TBI is you have ultimately a disproportional cytokine release. Lots of counter-regulatory hormones working against insulin. You ultimately going to end up with a hypermetabolic or even a catabolic state. There's impaired nitrogen homeostasis as well as oxidative stress. Basically, it's kind of a metabolic catastrophe in the brain. Oxidative stress, free radicals, we know about all this just from any kind of thing that would cause oxidative stress, toxins or any psychological stress. But you get cerebral vascular function, ultimately circulation and energy metabolism, and mitochondrial damage. This is almost the most important slide of the whole thing, in fact, that mitochondrial and energy metabolism is damaged. So that is sort of the linking factor metabolically, which we can all understand how TBI patients are suffering from the multitude of symptoms they are. You guys have heard, any neurosurgeons have probably heard of Robert Cantu. He says that the brain is in a metabolic crisis with concussion. Potassium ion from inside the cell going extracellular, calcium ions going intracellular, neurotransmitters widely released in a chaotic manner. It takes energy to pump that potassium back and put those neurotransmitters back on so the cell can function. So much here in a nutshell that he's just described. If you look at the neurobiological or neurobiochemical cascade that happens with a brain injury, ultimately those calcium ions going intracellular leads to cellular apoptosis and ultimately impaired metabolism and cell death. Sometimes the cells don't completely die, they go into a quiescent state. But the neurotransmitters, catecholamines go up, usually serotonin goes down. There's a lot of other stressors that occur, but it's an energy crisis. That's the best way to call a brain injury. And the whole etiology of how I treat, how I've treated brain injury needs to focus more on this energy crisis as a hardware repair. So very simple, energy crisis. What does mainstream treatments do? You guys are surgeons, you see brain injuries, you see these elevated intracranial pressures, you end up taking cranial flaps or relieves the pressure. That's great, that's awesome. But what happens after that? Where do patients go? Where do they go? They go to occupational and physical rehab, which is all good, speech therapy, get some medical management with medications, cognitive maintenance exercises. Sometimes the patients are simply told to just cope with their conditions. So past the neurosurgical realm of those acute stages of mild to moderate to severe TBI, ultimately what are we trying to do? We're trying to rehab these patients, but if you think about the brain like a computer, there's two functions, right? There's a hardware aspect to the computer and then there's a software. So a lot of these are reprogramming in the software. But if the hardware hasn't fully repaired, and I say this a lot, it's like running Windows 10 on a 386. You don't get good programming on a slow computer. So what we focused on is okay, these are great treatments that have to be done to some degree. You have to reprogram, you have to maintain the patient's state of mind using whatever drug therapy you need. But focusing on the hardware is also really important. Alternative treatments, you name it, there's brain injuries hot. Every day I see new brain injury treatments popping up, new clinics out there claiming they can solve TBI. It's a hot topic out there, whether it's the military, whether it's NFL, you name it, these guys are out there to go treat, and they got the treatment, the best treatment out there, right? Alternative treatments could be acupuncture, which is great, could be cranial therapy. The only challenge with this could be neurofeedback, is a lot of it is just very singularly one treatment focused. And a lot of it's very focused on that software, reprogramming, neurocognitive therapy. You have these functional neurologists, chiropractors out there. None of that's bad, except sometimes the software can't really progress until the hardware is improved. Which of the following are symptoms of a traumatic brain injury? Headache, insomnia, mood changes, cognitive and memory impairment, sound and light sensitivity, or all of the above? Oh, they do have the clicker. I made these questions easy, so what can I say? All right, what is the most significant pathophysiological reason why many TBI patients fail to recover? Inflammation, oxidative stress, impaired nitrogen homeostasis, impaired energy metabolism, aka the brain is in metabolic crisis. All right. Yeah, all of those things occur: inflammation, oxidative stress, impaired nitrogen homeostasis, but ultimately it's that energy metabolic catastrophe that's causing this brain to not heal. A very really easy way to explain this too is your brain is always working, right? It's always functioning. Your brain never sleeps. Neurologist tells you to go home and go rest your brain. Yeah, you might get a little rest by closing your eyes or not looking at a computer screen too much or things like that, not doing too many stressful activities. But even while you're sleeping, your brain is still consuming 20% of the oxygen that you inhale and 25% of the glucose you inhale. The brain never sleeps, the brain never rests. It's like telling someone with a sprained ankle or a broken ankle, you're gonna have to keep walking on your ankle and you'll heal that way. It's illogical. And I think that's the biggest challenge with some of the medical sort of advice to a lot of these patients is, hey, go home and rest. Nobody rests. With a brain injury, you're always working. The brain's always working. So, multimodal regenerative approach to the TBI. It's hypothesized that if we combine certain therapies, get the best bang for our buck, we can get a synergistic benefit that outweighs any of just the one particular treatment. So what did we do? Our goal was to see what we could combine that was synergistically important and would work together to basically maximize energy input to the brain. because that's what our goal is. I'm not a specialist in the software or reprogramming the brain. I'm not a specialist in the diagnostic aspects of TBI. There's all kinds of people doing fancy things with that. I'm a specialist in ultimately helping get energy most to the brain to help it heal. Hyperbaric oxygen. Anybody ever used hyperbaric oxygen? What's it used for? 95% of hyperbaric oxygen is primarily used for wound care, things like radiation, osteonecrosis, osteomyelitis, right? Most major hyperbaric centers are in hospitals. They kind of have the market on all of that. You know, big insurance contracts. Much easier to basically treat somebody's diabetic wound for $40,000 to $50,000 in the hospital instead of cutting off their leg and leaving them for good that way, right? So diabetic wound ulcers is probably the biggest indication for hyperbaric oxygen. Is it used for TBI? Yeah, there's some merit to that. Why? Because if your brain has to function and to heal, you need energy to do both things. One of the simplest ways to get energy is to give your brain more oxygen. When you give your brain more oxygen, you get in 10 to 15 times its normal amount. You're stimulating the tissue growth, bone and blood vessel growth, and reducing inflammation. Actually, oxygen in the hyperbaric oxygen world is one of the few approved ways of actually stimulating growth hormones and growth in the body. Anybody ever used a SPECT scan? SPECT scans aren't really highly thought of in the medical world in general, but they are pretty good for looking at blood perfusion, which is what we've used for this patient, a 51-year-old lady who was suffering from TBI. She got 40 hyperbaric treatments, and you can see the benefits of those treatments with the perfusion increased. Here's the pre, here's the post. Anybody ever diagnosed a traumatic brain injury with just a simple CT or MRI? It's not so easy, right? And that's why a lot of these patients go home and they're like, oh, you have nothing wrong with it. You don't have a bleed, and they get something home from the ER. And they're told that there's really not that much going on. But all the while, they're suffering from all these symptoms. So the SPECT scan is pretty good at understanding that. It's not the best for research purposes. However, these things have held up in the court. I'm gonna move this. Hyperbaric oxygen. What do we know about it? Increases neuroplasticity, increases tissue oxygenation, generates new capillary networks. And usually that's after about 25 treatments. You start to get new capillary angiogenesis, you get more blood supply, and even stem cells that get released into the blood. How does hyperbaric oxygen help TBI patients? Hyperbaric oxygen reduces neuroplasticity, causes vasodilation, increases tissue perfusion with new capillary growth, or creates oxidative stress. There you go. So hyperbaric oxygen actually causes vasoconstriction, increases neuroplasticity. And even though it creates oxidative stress, that's not a benefit. And the real key for hyperbaric oxygen treatments for TBI patients is not doing too much, too hard. A standard treatment for a patient with radiation osteonecrosis might be 2.4 atmospheres or 2.5 atmospheres. It's about 1.5 with traumatic brain injury. It's really easy to push the patients into an oxidative stress overload. And believe it or not, some of the biggest sources of oxidative stress are our own mitochondria. So you get those mitochondria spinning too fast, working too hard, making too much ATP, the fires of that actually ultimately can create more damage than good. So it's really the dosing that's really important with hyperbaric oxygen for TBI. All right, stem cells. What we know is that 2 hours of hyperbaric oxygen triples the patient's own stem cells. This is a 2.0 ATA. And you get 20 sessions, you get about 800%. So this is pretty significant. There's not a lot of drugs or anything else that can do that very easily. Here's some data. If you look at this is CD34 cells, better known as hemopoietic cells, that basically can make new blood cells. There's also a pretty newly discovered CD34 cell that's Lin negative. See, they looked at Lin positive cells in this study. And you can see before or pre, post, and then after they did 20 treatments, how much they increased. But you can get an increase in hematopoietic cells as well as something called the very small embryonic-like stem cell. Gets released from the bone marrow through hyperbaric oxygen and dumped into the blood at a much higher level. Studies on this were done by a guy named Steve Thom, MD, PhD, back in the early 2000s. And he said hyperbaric oxygen is the safest way clinically to increase stem cell circulation, far safer than any other pharmaceutical options. Stem cells are kind of a big thing nowadays, but you can't grow them up. In the United States, you don't culture and expand them except in special clinics and research facilities, which is kind of good because every time you grow and expand a stem cell, you actually age the stem cell. So it has less benefit. Increasing that stem cell in vivo instead of in vitro is probably the safest and one of the best ways to do it. Intranasal therapies. Anybody ever used anything, ever learned about intranasal therapies? Years ago, I learned about the intranasal insulin treatments for Alzheimer's patients. These were big NIH studies. I think they were done in the late 90s that looked at using intranasal insulin to help Alzheimer's patients. And what they found was that you could take a journey through the nose, go via the olfactory nerves through the cribriform fossa, and you could bypass the blood-brain barrier. You get insulin into the CSF within 10 minutes. So you could take insulin, put it up in your brain. As long as you got into the upper third of the nose, it would be detectable in the CSF within 10 minutes. You could do a lumbar puncture and pull it out, exogenously. That was the route they proposed. They did some studies on rats. They said there might also be another trigeminal route for which this cell, which insulin or any solution could get into the brain, but more likely to go into the cribriform fossa, cribriform plate through the olfactory nerves is the most likely route. What does insulin do? And this was, like I said, these were big NIH-funded studies. We realized that, hey, wow, insulin helps us create more ATP. That's pretty cool. Lowers CSF, cortisol, increases neuronal viability in the hippocampus, lowers ultimately gliosis by reducing the inflammatory microglia, and can even reduce beta amyloid and tau protein deposition. I don't know anybody yet. I don't know people who are doing insulin outside the clinical realm for this, but it's pretty fascinating. There's huge research behind this, and it's amazing. And getting back to the metabolic crisis, what do I want to do? I want more ATP, right? So I got the oxygen increasing ATP, stimulating those mitochondria to start making some ATP. Now we got insulin. Insulin is driving glucose and nutrients into the cell, so the mitochondria can stimulate. This is basically a slide that takes saline and throws into the brain, and then they're taking slices of the hippocampus of these rats, and they're looking at basically how much these neurons light up. And then you're also looking at anti-inflammatory microglia with saline as well as insulin delivered intranasally. Intranasal insulin has the following effects: increases ATP production and utilization, decreases gliosis, decreases cortisol, reduces amyloid and tau protein deposition. All of the above. Perfect. So yeah, I love ATP, but ultimately we're lowering all of these gliosis, amyloid, tau protein. Yeah, it's all great. So what they did find when they did these, they were actually using intranasal insulin. The doses were, and they're diluted doses, about 20 units for each nostril. As long as you get into the upper third with the patient's head tilted back and it gets into those olfactory neurons, you won't get systemic insulin into your bloodstream or any drop in blood sugar. And what they found with the Alzheimer's patients was they had improved word recall, improved balance, and ultimately improved declarative memory. Declarative memory is kind of like working memory. It's like RAM in your computer. Platelet-rich plasma. So this is my world of expertise as far as doing injections of PRP. Lots of growth factors. There are actually about 300 different growth factors. Some of these things are great for increasing angiogenesis, collagen growth, protein stimulus, IGF-1, insulin-like growth factors. So we're getting a lot of collagen growth. I mean, that's what a lot of the PRPs orient towards. That's why we use it for ligament, tendon, other types of injections. When you inject it, you also get an infusion of other platelets, so you get an exponential increase. So injecting plasma into an area, you actually, or infusing to the brain, you get an actual exponential increase in the other growth factors that come to the area. So you're creating kind of a growth factor party. And what you do is you get a mediating cytokine effect as well. So you're guiding stem cells as well, endogenous stem cells as well as stem cells you might actually place in the brain. We've actually cut the brains open of rats, not me, but somebody has cut the brains open of rats and dropped stem cells, certain ones, with this S100 beta as well as VGF, and increased neurogenesis by putting it on the Dante gyrus of the hippocampus. So we can create potentially neurogenesis with growth factors. Deliver it all through the nose. I mean, the orthopedic surgeons put plasma all around their, treatments, right? Brain surgeons, I don't know anybody. Do you guys drip plasma in the brain? Maybe? So peripheral blood stem cells. Like I said, we talked about hematopoietic CD34 positive. You can increase those with hyperbaric treatments. And now what we can also do is we can take those cells as they get increased, pull them out, spin them out, isolate them, and stick them back into the brain. Getting the growth factors guiding them with the platelet-rich plasma. And then we can basically work in combination with PRP. The great thing about these cells is they're very much like embryonic stem cells. There's hematopoietic cells and there's very small embryonic-like stem cells that we can use, and they have a very powerful regenerative effect. The stem cells we use are not BMA, but we've looked at other stem cells that have been delivered into the brain, and we've seen improvements with patients with ischemic brain damage. So this is just some of the studies that support using stem cells into the brain. We also see that these downregulate neuroinflammatory cytokines. Most BMA is what's called a mesenchymal multipotent or unipotent cell. It's really designed to have a paracrine effect. It doesn't necessarily turn into new brain tissue. This is bone marrow or fat stem cells, fat-derived stem cells. Whereas the ones we're using can turn into any kind of tissue based on the research. We also like to mix some of our plasma with a little glutathione. If you're creating more oxidative potential, you're going to have more oxidative stress. So we want to lower that oxidative stress by giving a powerful antioxidant, which is glutathione, it's more of a fat-soluble glutathione. We've seen some improvements with Parkinson's disease patients. You can also get improvements with intranasal methylcobalamin. There's some good studies that support improved QEEG theta activity for autism and ADHD. So what else do we want to do? Give them a little IV. Now this isn't going directly to the brain, but it's also systemically helping the patient to have more energy. So we're giving a little bit of plasma in the IV. We're giving NAD. Anybody ever use NAD? Widely used in addiction clinics, mostly to basically kind of reset how the patient has a dopamine response to a drug. NAD, NADH ratios are part of how we reset that response. But NAD is what it does ultimately in the body is it's one of the last steps on the electron transport chain to making ATP. So I give NAD both intranasally as well as intravenously and have this cocktail of Myers nutrients. Anybody ever had an IV cocktail? Gone to one of these IV clinics? Maybe. We use these a lot for hangovers and asthma. It's basically a banana bag. Cranialopathy. Anybody an osteopath in here? A few osteopaths? Anybody still use osteopathic manual therapy? Maybe a little. So cranial osteopathy, basically you're moving the cranial bones, or maybe some people say that they don't really move, other people say they do, but they have little sutures, and basically the cerebral spinal fluid moves those bones very, very subtly. And cranial osteopaths basically are tuning into this subtle rhythmic pulsation. If that rhythmic pulsation, which goes up and down the spinal column, the cerebral spinal fluid, 8 to 12 cycles per minute, gets impeded, it's kind of like having a dam in the river. If the dam is slowing that river, the brain can't get the nutrients it needs, it can't detoxify what it's got out. So you want to improve the flow of the CSF. And in a concussive event, that can create more of those dammed up river areas. So you end up with like certain parts of the river that aren't, or parts of the brain that aren't getting nourished. So we've seen improvements with vertigo and headaches with TBI just using cranial osteopathy. And this is why. When you have, it's a really complex slide, but basically they looked at the bioimpedance and the sort of the peak of these waves in a healthy person, as well as an athlete, as well as a brain injury patient. And then they measured transcutaneous Doppler and looked at basically where the transcutaneous Doppler sounds ended up. And they were able to calculate if you have a very close wave here with a TBI patient with the transcutaneous Doppler and the bioimpedance, that corresponds to the mobility of the CSF. That means ultimately their CSF is impeded in some way or moving slower. It's more like a stagnant lake or a cesspool rather than a healthy river. Athlete or a healthy patient, they have better flow, and that's what they were able to document here. And your next question is, TBI patients have reduced mobility of the CSF, increased mobility of the CSF, complete loss of the CSF, or no change in mobility of the CSF. There you go. You guys probably don't want me. So MCT oils and the ketogenic diet. I'll go through this pretty quickly. Anybody know what MCT oils are? Medium chain triglycerides. Anybody ever tried a ketogenic diet? Yeah. So what have we used ketogenic diets for brain patients in the past? Epilepsy, seizures, right? I mean, why does that work? Why is that help? So ketogenic diet, literally we're just trying to reduce the glycemic load on the patient. And you're trying to get enough protein, but also really the goal is a high fat diet. We're trying to reduce the amounts of refined grains, especially, and high glycemic types of foods, as well as sweets, honey, you name it, sugar. Letting patients eat more of a high fat, nuts, avocados, fat, meats, some sustainable. But yeah, that's the goal. And very simply, the analogy is this: if you throw kindling on a fire, it's going to burn hot and then it's going to burn down. You eat sugar, it's going to burn really quick and then it's going to burn down. TBI patients, many brain injury patients, even seizure patients, they're craving carbs, they're craving energy. They want that quick fix, right? But what they need to keep their brain stable is a good log, good long burning, like big log in their fire. And that's what the fats can do. These big ketones can burn much more effectively. The other analogy is ketones are more like diesel fuel. You throw diesel fuel on a fire, it doesn't flare up. It has a lower flash point. It's less flammable. But glucose is much more like gasoline. You throw glucose on the fire, it's just going to burn. You're going to get these quick fixes. What else do ketones do? Especially for seizure patients or for brain injury patients, what you're getting is increased GABA, you're getting more calming, you're getting more neuroprotection. You're lowering oxidative stress, you're lowering anxiety, you're lowering glutamate. Glutamate is a neurotoxin basically at the levels that you get in brain injury. It's just a simple chart. Basically, it shows where GABA is upregulated and there's decreased glutamate. You can look at this more in depth, but ultimately we're trying to reduce oxidative species here. The other great thing is promotes synthesis of ATP, limits glutamate toxicity, and stimulating these mitochondrial biogenesis. So it's an energy treatment. I mean, you're getting much more energy from that fat and a long burning steady energy. So here's our protocol. Some patients, if we can get them in a medical grade, we'll have them do at least 10 to 20 hyperbaric oxygen treatments. So we're wanting to upregulate those stem cells as much as we can, give them as much of the benefit of hyperbaric oxygen before we actually pull their blood and isolate out their plasma and their stem cells. Some patients can't afford or don't live near a hyperbaric chamber. There's only 3 of them freestanding in the state of Colorado. You can't go to the hospital and get these hyperbaric treatments. So we send them a home hyperbaric chamber, which we treat the patients at FDA-approved levels of 1.3 atmospheres, which is about half of what you would get in a medical facility. But it's still enough to increase what we need as far as oxygen and stem cells. So most of my patients, I'd say 50 to 70% of them fly in to come and see me either in my office near Aspen, Colorado, or here in Lafayette. We consult with them, understand what's going on, if we can help them or not. We give them IV treatments, cranial safety, hyperbaric treatments, and then we will do the IV PRP and nutrition. It's got insulin in it, and then we do the pluripotent stem cells on the day 3, mixed with NAD. It's actually not mixed, the NAD is administered first. And then we do that intranasally as well, followed by hyperbarics. They will also go home and complete another 20 medical grade hyperbaric treatments, or go home and then continue to use their home hyperbaric chamber. Usually I recommend for at least 9 months. Case report, 46-year-old male, had a severe TBI. He had significant issues, memory loss, depression, anxiety, he was emotionally unstable, headaches daily, insomnia. After treatment, he felt like he had a memory download, he had an awakening, he had improvements intellectually and psychologically, he was able to read. This guy's back to work, driving. His doctors called me up. This was one of the first patients I treated. Doctors called me up and, hey, what'd you do to this guy? And I basically told him the whole protocol, and we just started getting patients calling us from all over after that. So it was like a stream of information that had been let loose. I felt for the first time in a year had some clarity. I was excited and able to read more than 2 or 3 sentences without triggering a migraine. The ability to think and plan returned. Case report. 30-year-old female, she had a mild TBI from a fall. She had insomnia, mood swings, depression, unable to work, head pressure. After the treatment, she was able to work and travel. She had reduced sound and light sensitivity, improved mood, less fatigue, relief from anxiety. I'm going to skip this. 48-year-old female, she had mild TBI from multiple concussions. She had anger, depression, even suicide ideation, anosmia, she couldn't smell. Extreme mental fatigue. She was calm after the treatment, no longer reactive and irritable, no desire to commit suicide, confident, had improved sense of smell and memory. The results have been, for me, nothing short of miraculous. Popeye may have his spinach, but I have stem cells and PRP. Yes, my brain is strong. I mean, the great thing about treating these patients is they have their identity back. I mean, it's like you lose your brain. It's not like, breaking your leg or something. It's like a whole identity crisis. So getting their identity back was pretty significant. People ask us for other kinds of research, where's the proof? And so basically we started investigating these patients before and after with something called a Blobby Scan. Blobby is one of the few proprietors of something called a functional, I would call a functional QEEG. You guys have used QEEGs. What they're doing with these QEEGs is they're looking at the voltage between the amplitude of the waves. So they're taking the maximum height of the waves and looking at the voltage between those. And what we've done with these patients is looked at before and after. And can't totally see these numbers, but we've been able to see about a 10% to 15% increase after 2 months of drug treatments. You can also look at things like alpha-beta ratios, as well as closed-eye alpha coherence, and we've seen improved coherence in the alpha waves, which generally is a good sign of improvement for healing. And here's some before and after pictures. Literally, this is just a voltage map. There are some preliminary studies that have looked at DTI with comparison to the Blobby scans and had a great correlation. And what they're doing with this is actually looking at a sound that you have a regular sound, and then you look at the voltage change when you have an unusual sound. So that creates this. So there's no patient like having to respond to a certain like input or output. This is a 36-year-old male bomb tech. Before treatment, he had headache, suicide ideation, PTSD, depression, fatigue. Afterwards, no suicidal thoughts, more energy, able to exercise, less pain. And we can see his improvements here. I think it goes from 15 to 17 there. And also improved alpha or theta-beta ratios there. Out of 100 patients we treated, they had more mental clarity, improved memory, more stable emotions, better able to cope with pain, more physical and mental energy, and also improved decision-making and executive functioning. Overall, some patients report some less down in light sensitivity, improved eyesight, improved sleep, libido, improved motor function, and less muscle spasticity. In conclusion, a multimodal regenerative approach is a superior way to treat TBI, ultimately because there's synergistic benefits to combining these therapies all together. This is still all in the pre-research phase. We're working with a nonprofit called the Invictus Project to create a study, and basically we're doing some of these same protocols to determine. We'll combine Blobby scans as well as DTI to get sort of a pre and post, and then do some of the same protocols that I've discussed. Sam Peterson is one of the founders of the Invictus and also a military bomb tech. These guys are basically just out there to try to help their vets. The reason they exist is because the VA SOPs really just haven't worked. I had a job offer to go work for the VA at one time, and I was like, your SOPs just aren't cutting it. So the stats now for guys just like this is 22 of them every day are committed suicide. So, and I don't believe it's from PTSD entirely. I think TBI is a large component of why they're in this state.